The very brief one in the very, very beginning will just take a couple of just notes of a sentence about them. And then after my minor stories are done, we will move right into the major stories of the year, and we will lead off with Bob Trembley. And Bob Trembley will be doing the history of the Cassini Mission. Each of the major stories will take approximately 10 minutes. The faster they get done, the more chance you have to have questions. So that's just something as a bonus. The second story will be Jeff MacLeod, who will be doing the information from the Juno spacecraft that went around Jupiter. The third story is the TRAPPIST-1 story of the exoplanets that were found this past year, that several of which were in the habitable zone of a star. The fourth story will be Diane Hall, who will do the solar eclipse, which was a major story. And the final story will be gravitational waves and the neutron stars colliding, that will be given by Jerry Dunifer. If you have any questions, again, I will let you know when we have time to do those as we go through this. So without further ado, we'll start our first set of stories. This is in the news for 2017. These are the second 5 stories that didn't make the cut, but there's quick stories here that we want to mention. First of all, it was the death of Gene Cernan, beginning of the year. Voyager was turned on after a number of years in being quiet. There's the invasion of the extrasolar asteroid. That's an artist's conception, by the way. That's not what it looked like. And the the star that wouldn't die. There was a star out there that looked like it went nova, and then it just kept coming back. And that was the first time we'd seen that. And the last of the real quick stories is the James Webb Telescope development and testing, which we'll have a lot more about that this year when it gets launched. The first story of the minor stories was the scientists' witness of a huge cosmic crash finding the origins of gold. Astronomers strike cosmic globe confirm the origin of precious metals in neutron star mergers. First destruction of life from neutron star merger reveals new cosmic phenomena and opens a new field. That's the University of California, Berkeley study. Many thought would be a long way off. The detection of gravitational waves from the merger of binary neutron stars actually happened on August 17th. The observation of a blue and red glow from the radioactive debris cloud left behind matched simulations that merger would look like, proving that such mergers are the source of most of the heavy elements in the universe, including gold. Second story. There's also, that's what I want. Okay, let's move on from there. Let's talk about the Tabby star. Tabby star. They're looking at the dimming of this star called Tabby star. The observation reported that there was maybe some alien megastructure, but we've discovered that in fact it was caused by there's a dust that actually, it's long since crumbled dust and dips in the weird star life. It was almost definitely caused by a ring of dust, not a huge opaque object between us and the star. In 2015, a team of astronomers led by Yale's Tabitha Boyan saw the light from the star KIC 846-85 suddenly and repeatedly dip and die in brightness. It dimmed up to 22% over several days before normal, and then it dimmed again in May. And we found that light was not dimming in all wavelengths, indicating whatever seems to be blocking is a solid, can't be a solid opaque structure. This means that the idea that this dimming would be caused by an alien megastructure is now even more unlikely. Instead, it's straight to say that there are probably dense pockets of dust circling the star. Mars updates. First of the Mars updates, researchers suggest that early Mars may have been intermittently warmed intermittently by powerful greenhouse effect. This found interactions between methane, carbon dioxide, and hydrogen in the early Martian atmosphere may have created warm periods when the planet could support liquid water at its surface. analysis of the Martian meteorite found in Africa in 2017 has uncovered evidence of at least 2 billion years of volcanic activity on Mars. At the mouth of the Mars mega flood, ESA released a beautiful image on March the 2nd. It's a capture of its Mars Express spacecraft of the mouth of one of the largest outflow channels networks in Mars. You can see a channel indicating the extending to the right from the huge crater on the left. The combination of volcanism and tectonics and collapse subsidies in the Tharsis region led to several massive underground releases, groundwater releases from Ekes Chasma, which subsequently flooded the Castle Vales region 3.6 to 3.4 billion years ago. The NASA orbiter tracks back-to-back regional storms. This is the third picture up there. There's a Mars, come up here. There you go. There's a Mars volcano. Earth dinosaurs went extinct about the same time. This is a March 21st report. New NASA research reveals that the giant Martian shield volcano Arsia Mons produced one new lava flow in its summit every 1 to 3 million years during the final peak of activity. The last volcanic action there ceased about 50 million years ago, around the time of the Earth's Cretaceous Paleogene extinction. The next story was the MAVEN, the NASA orbiter MAVEN. Mars lost 90% of its CO2 into space. It vanished into thin air. Around 90% of the red planet's atmosphere has probably lost to space over just a few 100 million years, according to key measurement of the NASA's MAVEN spacecraft. Today, Mars is a freezing, arid desert. It also revealed that there was metal in its atmosphere in April. Mars' atmosphere harbors a layer of electrically charged metal atoms, and they have not been behaving as expected. On April the 27th, Mars is known to having the largest volcano in our solar. Olympus Mons also found small-scale volcanic features on its surface, as shown in the image. High-rise on board the NASA's Mars Reconnaissance orbiter. Rover findings indicate stratified lake in the ancient Mars, where it carried more oxygen at certain times. This is a Juno report. There is also Halo's discovery in Mars widened time frame for potential life. May 30th, lighter tone bedrock that surrounds fractures and comprises high concentrations of silica called halos has been found in the Gale crater on Mars. And flowing sand, not water, this is the big story, on Mars on November the 21st. The dark streaks known as recurring slope lineae are likely the result of repeated avalanches of sand and dust not seeping water, as was originally reported. There you go. The discovery of a dipole repeller confirms that both attraction and repulsion are in play in the intergalactic neighborhood. This is a Hebrew University of Jerusalem. What is propelling the Milky Way's race through space by 3D mapping the flow of galaxies through space. Researchers found that the Milky Way galaxy is speeding away from a large, previously unidentified region of low density. Till now, scientists assumed that a dense region of the universe is pulling us toward it, in the same way that gravity made Newton's apple fall to the Earth. Initial prime suspected is called the Great Attractor, a region of half a dozen rich clusters of galaxies 150 million light years from the Milky Way. And they are also talking about a large repeller that is on the other side. The Milky Way, we've been able to see it using the Milky Way's far side, using parallax to directly measure the distances to the star-forming regions of the opposite side of the Milky Way galaxy, nearly doubling the previous distance record. By using VELBA, we now can accurately map the whole extent of the galaxy. Dark matter was mapped on March 1st. The Yale-led team has produced one of the highest resolution maps of dark matter ever created, offering a detailed case for the existence of the cold dark matter. Sluggish particles that comprise the bulk of the matter of the universe. How most of the antimatter in the Milky Way forms, there was a mystery solved for that. Antimatter is a material composed of the antiparticle partners of the ordinary matter. And then when antimatter meets matter, they quickly annihilate in a burst of energy in the form of gamma rays, and we now have a remnant of that. And there was explaining the accelerating expansion of the universe without dark energy. There was an ignitic dark energy thought to peak up 68. May not list it all for another Hungarian-American team that says that it's a possibility that that is in fact not the driving force. The last of these stories is the first image of dark matter web that connects the galaxies, and this is another report on that from the Royal Astronomical Societies. This is the first composite image of dark matter bridge that connects galaxies together. A gravitational wave kicks monster black hole out of the galactic core was another story, and supermassive black holes found in 2 tiny galaxies for the very first time is also one of the stories. So those are the brief stories that we decided didn't make the cut, as they say. And with that, I'm now going to bring forward Bob Trembley, who will now discuss the Cassini Mission.
I'm going to talk about Cassini and Saturn. I am Bob Trembley, and I just want to say that my notes aren't here.
Oh, those will be on here because you don't have them on this one.
Okay. This was one of the hardest things I've ever done because I could talk about an hour and a half on this thing easy. So Cassini was launched in 1997. It spent several years in the inner solar system and doing flybys and doing gravitational assist to get the boost it needed to get out to Saturn. It went into orbit around Saturn in July of 2004, July 1st of 2004. This is one of the first images I can remember Cassini returning of rings, and I was just, oh my God, that is so cool. So Cassini performed dozens of flybys of Saturn's moons. 127 of them were flybys of Titan. Saturn has 62 known moons. Most of them are composed entirely of ice. And here's a few. Tethys, Dione, Rhea, all big blocks of ice. Hyperion, I love this guy. Iapetus, this has a whole huge story behind it. Don't type it in, sorry. Prometheus orbits within Saturn's rings, and you can see the gravitational effects it's having on the rings. And Saturn has a lot of these called shepherd moons. This is Daphnis. I looked that up. That's a weird pronunciation. And Pan, weird-shaped little flying saucer Pan, also orbits in the rings. Mimas has taken a lot of flack. All right. At first, it was compared to the Death Star, rightfully so. And then, after Cassini's thermal imager found an odd thermal anomaly in Mimas, it was compared with Pac-Man. Enceladus. Enceladus is a very interesting moon. What you're seeing here, the blue stripes on the bottom, are called tiger stripes. Plumes were discovered spewing out of these tiger stripes at various stages during Cassini's orbit. Cassini flew through these plumes and found they contain ice, organic compounds, volatile gases, carbon dioxide, carbon monoxide, salts, and silica. As Enceladus orbits Saturn, the moon gets stretched, and Saturn's gravity causes friction within the moon, generating enormous amounts of energy. It's hypothesized that Enceladus has hydrothermal vents and a vast ocean beneath its icy crust. Hydrothermal vents on Enceladus could be very similar to those found on Earth, which can host rich ecosystems. Enceladus has become a prime candidate in the search for worlds where life could exist beyond Earth in the solar system. Titan is one of the largest moons, is the largest moon of Saturn. It's larger than the planet Mercury. Titan's surface is hidden under deep, hazy cloud layers. It has, I think I missed one here. It has, pardon me?
Yeah, it's there.
Oh, okay. Okay, it has, Cassini witnessed a polar vortex on Titan. And Cassini studied the complex chemistry of Titan's atmosphere while it was there. It saw an island appear where one did not exist before. Now, Titan's atmosphere is really bizarre. It reaches up to 1,200 kilometers, and the orange haze layer up to 300 kilometers. So it's a very, very deep, tall atmosphere. Hydrocarbons in the atmosphere might make for some interesting chemistry on the surface of Titan. It would be an interesting place to go. So we did. And my slide's missing.
It'll be there.
Okay, well, the Huygens Lander was hitchhiked on the Cassini spacecraft and detached on December 24th, coasted for 20 days before reaching Titan. And it took several hours, about 2 hours, for it to descend through the atmosphere. It was taking instrument readings the entire time down there. And it is, the Huygens Lander is the first spacecraft to land on Titan and is the most distant landing ever achieved. Oh, there we go. Yeah, so we did. So we went there. And that's what it looks like. Now, it's really interesting. I didn't know this. This thing's 9 feet wide. I was thinking something like this. I'm like, 9 feet? That thing's huge. So, Cassini also saw dunes on Titan, which could be shaped by static electricity. They're not quite going with the prevailing winds. Kind of odd. This is what the Huygens lander saw on the way down toward the landing site, and that image is over on the left there. There's a video of that. It's really, really cool. Cassini saw rivers and lakes of liquid methane, or rivers flowing into lakes of liquid methane. And additionally, it saw changes in the Titan's atmosphere over the years it was observing. Cassini also observed a megastorm in Saturn's atmosphere. It lasted for several months. It witnessed Saturn has this weird hexagonal thing at the North Pole. And over the course of 4 years, this region changed color as summer reached the northern hemisphere. Cassini took tens of thousands of images of the rings, and here's just a couple. Some eye candy here. I love this. This is really cool. Shortly before equinox, Cassini imaged these vertical structures towering as high as 1.6 miles above the plane of the rings, casting long shadows. Oh, they're really cool. And these propeller-like structures are gaps in the ring particles created by tiny moonlets, smaller than the known moons, but larger than typical ring particles. And there could be millions of these in Saturn's rings. NASA did a huge promotional campaign. They called it the Day the Earth Smile. They had everybody smile and wave at Saturn at one day, and this was the image that they took. And it's just beautiful. But that little blue dot down there, that's Earth, and everybody's doing that at the same time. So Cassini flew by Titan on May 6th of 2016, altering its trajectory into the start of its grand finale orbits. It kept reducing its orbit and getting closer and closer and closer until it's outside the F ring here, and closer again until it's in the start of its innermost, the proximal orbit. This takes the orbit between the cloud tops and the D ring, and we've never gone there before, and it was kind of scary. Cassini did 22 of these orbits. During the last 5, Cassini was able to sample Saturn's upper atmosphere. And as Ken mentioned, it discovered this weird coupling effect between the cloud tops and ring particles. September 15th of last year, Cassini was close enough to Saturn that it started experiencing significant atmospheric drag, and Cassini burned up in the upper atmosphere of Saturn and in the mission. Oh. I cried when I made this. I did. And there's Cassini by the numbers. 8 minutes, 4 seconds.
It's like,
Yeah.
You have a minute of questions for him.
Oh, wow.
or we just sitting around, okay,
You have any questions at all? It's okay. One question only.
So we've learned a lot, obviously, by Cassini. What do you think has been the greatest achievement or thing that we've uncovered from this exploration?
Man, there's so much there, but I think the fact that it was, like many of the things we've got now, the lunar reconnaissance over the Mars reconnaissance, it was a reconnaissance orbiter. it orbited a long time, and it studied it over, what, about half its orbit. So it's very, having a long time orbiter is very valuable when studying these other planets, and I'd like to see something around Uranus and Neptune.
I think that maybe that the Enceladus discoveries were pretty significant. All right, our second speaker. Thank you very much, Bob. Great job. Our second speaker is our illustrious new president, Jeff MacLeod, who will talk about the Juno mission. All you need to do is touch that your next thing. There you go.
I like that.
That's not one of my slides.
Yeah, it is. Yeah, it is.
I took them out.
You didn't take them out when you sent them to me.
Oh God. All right, why do I skip that? Because that had nothing to do with Juno.
Go for it.
Oh boy, this is going to be interesting. It didn't update when I sent it to you?
It gave me, whatever you sent me went into
Oh, man. Okay.
President Jeff MacLeod.
All right, you want to see me ad-lib a Juno presentation? Here it is. So I wanted to give you some background into Juno. Are those slides in? Well, anyway. Okay.
We'll all find out together.
At some point, we'll know when it launched and when it got there. This is from the Juno flyby of February 2nd, and this is showing an interesting feature called the North-North Little Red Spot 1. Don't ask me how they name them that. I had to Google it to make sure there just wasn't two norths in there for some reason. Most of the Juno stuff for 2017 is going to be eye candy. Science takes time, and most of the actual science of Juno is done in a 2-hour window at Perigove, when the satellite is actually closest to Jupiter. So let's skip this. So this is from the flyby of February 1st. I believe it's the 4th science pass. So Juno arrived at Jupiter in 2015. It has a extremely elliptical 53-day orbit, so it's going way out, not doing much, and then when it comes really close to Jupiter, that's when they're doing all of their science, and then they wait for the next pass. So this is the south pole of Jupiter on the 4th pass. OSIRIS-REx is not Juno.
Oh, there were some other things that you had in there that
yeah, we'll get to them. So there's a lot of things that Juno is helping other scientists do. So there's a lot of, this is also north little spot, north, yeah. Okay, so this is from May 25th, and there was a lot that came out on May 25th. This was the first story from the University of Leicester. New observations about the extreme conditions of Jupiter's weather and magnetic fields. Astronomers have contributed to the revelations and insight coming from so this is from the first flyby. So in 2015 they had a flyby. 2 years later, now we're really starting to get some of the data out of that flyby. And I think the next slide, this is a lot of the stuff that they got out of that flyby. Let's see if I can find it. The planet's interior core appears bigger than expected. Swirling electrical currents are generating surprisingly strong magnetic fields. Aurora lights shining in Jupiter's polar region seem to operate in reverse than those on Earth. So rather than the auroras coming down the magnetic field to the pole, Jupiter is exciting electrons away from the poles. And that was super surprising to scientists. And a belt of ammonia may be rising around the planet's equator. So all of those stories kind of broke around the same time from the first pass that happened in 2015. Juno sees Jupiter's Great Red Spot. This is July 12th, 2017.
That might
motion. I think.
Yeah, it's in real time. It's big. It's slow. Can't see it moving.
That's long enough.
So it says, these highly anticipated images of Jupiter's Great Red Spot are the perfect storm of art and science. With data from Voyager, Galileo, New Horizons, Hubble, and now Juno, we have a better understanding of the composition and evolution of this iconic feature, said Jim Green, NASA's Director of Planetary Science. And this was from, I believe, the 7th Science Pass. What's this date? This is July 12th, so maybe that's the 6th one. This is, I believe this is from the 7th pass. This is August 3rd. This is, again, north-north Little Red Spot 1. And this story was about the change in color. So normally this thing is red, but we're seeing this band of white on the outer perimeter. This is a anticyclone. It has been tracked since at least 1993, but maybe older still. An anticyclone is a weather phenomenon where winds around the storm flow in the direction opposite to that of the flow around the region of low pressure. And this is the 3rd largest on Jupiter, measuring around 3,700 miles in length along the long edge there. September 14th, 2017, Juno sees Jupiter up close and personal. A series of images from Juno spacecraft 8th flyby of the gas giant. When the Juno cam snapped these images during the 8-minute flyby, Juno ranged from around 5,700 to 14,000 miles above the cloud top. So I mean, and this isn't the closest path. There were some that took it to within 2,600 miles of the cloud top. So it gets extremely close at some of these points. So just more eye candy of Jupiter there. October 30th, University College London, Jupiter's intense northern and southern lights pulse independently of each other. According to the UCLA-led research team, ESA's XMM Newton and NASA's Chandra X-ray observatories found that Jupiter's south pole, well, this image is from Juno, but the study published on October 30th found that very high energy X-ray emissions at Jupiter's south pole consistently pulse every 11 minutes. Meanwhile, at the North Pole, they're erratic, increasing and decreasing in brightness independent of the South Pole. And they're going to be using a lot of Juno data to try to figure out exactly what's going on there. And so I believe this is the last patch. This is the 8th flyby on November 10th, and it's just going to be a lot of eye candy for you guys. So this was all Juno cam pictures. So hopefully I can click this and it
Here it goes. How about it?
keeps going. So this is, 4,000 miles above the cloud tops. So extremely close. And now this is obviously, as the spacecraft is getting further away, you're seeing more of it. Auroras. All right.
There you go. Thank you. Questions?
I don't know anything about Juno.
What are the science objectives of the pictures? This is a pure question.
Yeah, to make money for NASA so they can send more probes to other places. I had a slide in there next time. Juno looks small, and there was a lot of jokes about, they send, Jupiter's wife to check in on him. And the reason they named it Juno is because in the mythology, Juno was the only one that could see past Jupiter's kind of veil of secrecy, and so there's a lot of symbolism there. But it's not a small spacecraft. With the solar arrays deployed, it's almost the size of a basketball court. And when you think about sending something into orbit around Jupiter, it's a pretty impressive technical achievement.
Also, all of Jupiter's moons are named after Jupiter's various not extramarital affairs. So.
Thank you, very well done. We're still within time, and we're doing great. Next presenter will be Jonathan Kade, past president and now our first vice president. Jonathan will be giving a story about the TRAPPIST-1 discovery. And which is one of the lead ones. And you can do that by touching it on the All right. All right, so I'm starting out with the prettiest picture. This is an artist's rendition from NASA JPL of what this system looks like. So who remembers what TRAPPIST-1 is? Oh, no, that was the other, that was Tabby's star, and Tabby's star is not a Dyson sphere. So TRAPPIST-1 was discovered in 2015. Astronomers from the University of Liège in Belgium discovered 3 exoplanets that were orbiting a red dwarf star that was at the time known as 2MASS J2306298-0502285. There's going to be a test.
Catchy.
On February 22nd, 2017, they, working with about 25 other researchers at different institutions, announced the discovery of 4 more terrestrial planets around this red dwarf star. So the goal of the study that was published in 2017 was to find and identify the temperate terrestrial planets. And what's really neat about TRAPPIST-1 is that because it's a red dwarf star, the temperate zone is pretty close to the star. So we're in what we think of as the habitable zone of our solar system, but in a red dwarf star, the habitable zone is much closer in. So even though, we'll talk about it in a second. So the way that they found these planets around this star is by looking at the dips in the light of the star. Excuse me, I'm still getting over something. So the fact that all of these moons orbit actually in harmony with one another, and that allowed them to more easily pull the dips in the data out from and separate them and determine each one. So the reason that it's called TRAPPIST-1 is that it was the first planetary system discovered by the TRAPPIST Observatory. Now it's TRAPPIST South. It's at La Silla Observatory in Chile in the Atacama Desert. So it saw first light in June of 2010, and TRAPPIST is a backronym. It stands for Transiting Planets and Planetesimals Small Telescope South. There's another one in the Canary Islands now. Now, why is it called TRAPPIST? Well, if you are familiar with Belgium, you may know of the monastic order known as the Trappist monks. But that's not why it's named that. It's named that because those monks made really good beer. So it's named after Trappist ale, because that's what astronomers do. And for more on this, see me at the Red Coat. So how does it compare to our home solar system? So this is a little bit hard to see. I don't see a laser pointer up here. Can I touch the screen?
You can,
No.
I don't think it'll do anything.
Okay, so basically, this circle here is Mercury, the orbit of Mercury.
Looks like an ellipse.
The ellipse, the very circular ellipse there is the orbit of Mercury. This orbit here is Venus that just barely clips the frame. So this entire star system is just less than 1/5 of the area bounded by the curve of Mercury's orbit. So it's a really, really tiny star system. But as a red dwarf star, TRAPPIST-1 has only 8% of the sun's mass, it has 11% of its radius, and it has 0.1% of its volume. So TRAPPIST-1, in terms of the actual dimensions, is only a little bit bigger than Jupiter, even though its mass 100 times more massive than Jupiter, or 1,000 times. So the main thing that we've learned about it as the year went on, and this was announced in October, is that the planets in the system have resonant orbits, so they all interact significantly with each other gravitationally. So in the time that the innermost planet completes 8 orbits, the second planet completes 5 orbits, the third planet completes 3 orbits, and the fourth planet completes 2 orbits. So you want music of the spheres, here's your music of the spheres. So the other nice thing excuse me, about the harmonic orbits of this system is that in addition to making it easier to tease out the light curves, it also allowed scientists to compute the masses of every single one of those planets except for the outer one. So the total mass of the 6 inner planets is approximately 0.02% the mass of TRAPPIST-1, which is a very similar ratio to Jupiter's moons, as Jupiter's moons have to Jupiter. And it's an observation that suggests maybe a similar formation to the Jovian system. So on the 31st of August 2017, we pointed Hubble at the TRAPPIST-1 system, or excuse me, we had pointed Hubble at the system earlier, but astronomers looking at the data actually announced that they had found some evidence of water atmospheres in the system. They haven't been able to figure out which system is which. But you can see many of these planets, the F planet and the C planet, are almost exactly 1 Earth radius. The G planet is a little bit more massive than Earth, and the C planet is also a little bit more massive than Earth. So we're talking about things that look very much like home. Now, why, I'm sorry, didn't mean to. So we have a less massive, less energetic star than the sun. We have a closer inhabitable zone. We have potential water content on these planets. So why aren't we super confident that there's life on them? Well, the problem is all of these planets are tidally locked to the star. The same side of every planet faces the star all the time. So that prevents the sorts of atmospheres that we have on Earth. It means that the side facing the sun is not habitable by any means. The side away from the sun is probably also not habitable. And then beyond all of that, the star, as a red dwarf star, has a strong X-ray, extreme ultraviolet radiation, and it also goes through extreme solar flares. Now, based on our experience in this solar system, we think that those things are really bad for life. Now, obviously, we're very biased because we live in the solar system we live in and not TRAPPIST-1. So maybe there is life there, and it's just not life as we know it, Jim. So, what is next? Future observatories, most notably the James Webb Space Telescope, which is launching in March, as well as the European Extremely Large Telescope that is going to be coming online in the near future, are going to be able to measure greenhouse gases in these planets' atmospheres and otherwise look for signs of life. Despite all of the apparent odds stacked against life in the system, it is by far the most hospitable system that we have thus far discovered outside of our own. So I think it was a really neat story. And if you'd like to meet a TRAPPIST close up, go to the red carpet. Thank you.
Okay, now to our 4th story, and probably one of the most important stories of the year. Former president and now our outreach director, Diane Hall, will give a presentation about the solar eclipse.
All right. Are you gonna navigate it, Ken?
You can do it.
Okay.
I'll treat it afterward. We're good. Just push the side that's the picture side, and then go to the next thing. That's it. There you go.
All right, so the Great American Solar Eclipse, as it has been dubbed. For many of us, it was the first total solar eclipse to touch the lower 48 of the US in our lifetime. We had not experienced one since 1979. Don't know about you, I didn't exist then. Now, the Great American Solar Eclipse of August 21st of last year dominated the astronomical calendar like nothing I've seen since probably much ballyhooed planetary alignment back in May of 2000 that was supposed to bring the end of the world. And before that, I would say Halley's Comet. Those were huge events that we heard about for years, even if we didn't even see anything and the world didn't end. Well, this was something that we told everybody about, I would say probably for 3 years. Now, what made this one so great? Well, we've got a little animation for you. So the Eclipse Path begins in Oregon. It moves through Idaho, Montana, Wyoming, Nebraska, Kansas, Missouri, Iowa, Illinois, North Carolina, and then exits in South Carolina. It hit many major cities along the way: St. Louis, Missouri, Nashville, Tennessee, Columbia, South Carolina. The path of totality ranged from, you can see there's a little range of time. It wasn't very long. It topped out at 2 minutes 40 seconds in the town of Carbondale, Illinois. Still, 2 minutes and 40 seconds of totality is really impressive. The world has changed a lot since 1979. Astronomy's changed, the way that we approach things and teach things has changed. Now, past US eclipses, like a prior Great American Solar Eclipse of 1878, had their own brand of hype. For instance, John Philip Sousa marches. These days, we approach things a little bit differently. And I'd like to take a few minutes to share with you one of the coolest simulations created to prime people for this event and to help you select where you would experience this event.
It'll start.
Yeah, it should start any minute now. Can you speed up through it though a bit, Ken?
Hard to do.
Okay. It's a little 3-minute animation. It's really cool.
Yeah. Oh.
Yeah,
No. You can do it.
should be. Nope.
Here you go.
Yeah.
Come on, there you go. Come on.
It worked on my laptop.
It works here too. That should do it.
I could also fast forward.
Here you go. We can start. Yeah, it's
Yeah, okay, good. Now, dig this if you didn't see it before. We did show it to you last year, but it is cool.
There it goes.
Might want to shout out if you see your viewing site hit the screen here.
Take a look at the top, by the way. We'll show you where you are, the local time, the duration of totality, and the speed at which the shadow is moving across the Earth, also the path width.
Yeah, this made it helpful in trying to select a viewing site because you could see, even if you were at a place along the path, how far you were off from the very center of the center line obviously determines how long an eclipse you're going to see. So you can see Jackson there in Wyoming. Yep, Tetons. Casper, of course, being one of the big hiked areas. All right, Nebraska.
I was there. Harris, Nebraska. Cowboy.
You can see it getting wider and wider too.
Grand Island. It's a well-hidden island. It's a very weird river.
Almost all the way across the path, by the way, just as a sidelight, it was clear. We had very few places where there was clouds.
St. Joseph was one of them.
St. Joseph rained out.
Yeah.
Columbia.
Yeah, we'll start speeding up as we approach the longest duration.
We're getting there now.
Yeah, here we are in Illinois.
Well, it slows down as it gets to
And Carbondale was half and half from what we heard.
Downtown Carbondale. goes 30 miles south and it's great. South of Carbondale.
There's a dynamic that goes with this. What happens is when the sun gets covered, we have a drop in the temperature that isn't really that much, but at the top of the clouds, the temperature really starts dropping as soon as it starts doing it. And when the temperature drops radically the way it does, that makes clouds dissipate. So your lighter clouds started to dissipate, and of course the very heavy ones couldn't, but the lighter ones you could. So that's why many places cleared up right before the eclipse.
And we're done. Okay, so that got a lot of us excited, and then we spent time preparing. So did the rest of the country across the Eclipse Path. Local science institutions, local government institutions, chambers of commerce spent years in preparation, while astronomy clubs like this one did their best to educate not just the general public, but our own members as to how to maximize the solar eclipse experience. I know that I learned a lot from people here like Ken and Cheryl and Alan Kaplan and Marty and people who had seen one before. While many communities put together helpful websites to help get people into their town to see the eclipse, many other businesses decided to exploit it by jacking up their hotel rates, insisting people stay for 3 to 7 days at a hotel, and despite this, hotels booked up a year in advance easily. Somebody already mentioned the weather woes. I'm not going to go into the drama on August 21st itself, but from our site in Grand Island, Nebraska, we had some anxiety. But as Ken said, the sun has a sort of it's not magic, but it feels like magic, a way of clearing out right at the perfect time. And so many of us did get lucky. Those of us who witnessed it in person took note of a wonderfully spiky corona and visible pink prominences, captured well in countless photographs, one of which is featured in our calendar. The planet Venus was easily visible during the totality, and also you could see the star Regulus hovering right near the corona. And true to the advice I was given by club members, I did not take any pictures myself, but I did have some fun with the shadow projections leading up to the eclipse. I think shadow projections are amazing.
What's happening here?
So what you're seeing with this projections is the sun is a crescent, and anything that projects the sun, whether it's a pinhole camera, a hole punched in a piece of paper, or the shadows passing through leaves on a tree, will be that crescent shape. So you can see a gibbous sun, a crescent sun, a tiny little sliver of a sun, and then hopefully you're looking up at the sun when it's completely gone. But this is, to me, magic hour, when the sun is doing that. Oops. So, reported 215 million people, that's 88% of the US adult population, witnessed the eclipse at some point on its path, or electronically. That's twice the numbers drawn to recent Super Bowl broadcasts, more than 30% above the rate of adult participation in the most recent US presidential election. It's also greater than the number of Americans who report brushing their teeth daily. The NASA broadcast alone of totality drew 4.4 million viewers, and this may have been the most watched solar eclipse in all of history. And the result, demonstrated Americans have an appetite for science, at least when accessible and properly marketed. And as to the economic impact, I picked Nebraska because that's where I was, along with my husband Jonathan and our friends the Kucheras. Nebraska reported $127 million windfall in tourist dollars from the estimated 700,000 tourists who showed up, making it the state's single largest event on record. It was a show. If you missed it, there's going to be one in 2024, and we're going to tell you all about it as we get close to that. Thanks.
America decided not to think it was one of the leading stories of 2017. I can't. All right. Okay, our final story, and the chief story of the year, and we are right on time, is with Jerry Dunifer, our professor emeritus. He will give the story about gravitational waves and the neutron star collision in general. And you're on your way. All you gotta do is push this like that, and you're on your way.
Push that.
And then, no, this one here. I'm sorry.
Which one?
There you go. You're on your way.
Which one?
This side. You always push that one.
Okay, gotcha. Go for it.
Okay, well, 2017 was an interesting year because there were a number of reports which came from LIGO, the U.S. gravitational wave detector, and also Virgo, the European gravitational wave detector, which came into operation towards the end of the year. So in October, they announced the Nobel Prize in Physics, and it went to these three gentlemen, which I talked about earlier. Rainer Weiss, Barry Harish, and Kip Thorne, for their contributions to LIGO and the detection of gravitational waves. So this is supposed to be animated, and doesn't appear to be, but when two massive objects are in close orbit around each other, as they orbit at very high speeds, approaching the speed of light, they generate intense gravitational waves, which suck energy away from the orbiting pair of objects, causing them to move closer and closer and eventually collapse into a single object. And this is another animation that's not working, showing the discovery of the first two black holes, which merged, which gave rise to a lot of excitement at the time, and much more has followed since then. This is an example, one gravitational wave detector, the one over in Europe and in Italy. This is Virgo. It has two perpendicular arms, each 3 kilometers long. We have a pair of these in the US, one in Washington State and one in Louisiana. And they have arms which are 4 kilometers long. And what we're looking for are small oscillations in the length of these arms as the gravitational wave goes by. Because the gravitational wave is, in fact, oscillations of space itself. And this shows the data which was observed for the first merger at our two sites, Livingston, Louisiana, and Hanford, Washington. The heavier curves are the observations, and the lighter curves correspond to the theory, Einstein's theory of general relativity. One can see how good the fit is by optimizing the fit. One determines the size of the initial objects, the size of the final objects, the spins of the objects, and the distance of the object from Earth. What is displayed here is the strain, the fractional change of the length of these arms, which is indicated to be of the order of 10 to the minus 21. So what they are observing are changes in the length of the arms corresponding to a distance of about 1,000th the diameter of a single proton. So these instruments have incredible sensitivity. This just shows data for the first 5 gravitational waves which were observed. And since we are looking with at least 2 detectors, the difference in arrival time at the detectors gives a rough indication of where in the sky these objects are located. And these correspond, in fact, to some hundreds of square degrees. But when Virgo came into operation, so that there were 3 observers at the same time, they were able to localize the area in the sky much better, down to just say 20, 30 square degrees, something like that. Now this is an indication of some of the collisions and coalescences which have been observed for black holes. There are a total of 1, 2, 3, 4, 5 black hole mergers, which are shown here. And very exciting is the merger of two neutron stars into an object which could have ended up as a massive neutron star or a low-mass black hole. This, I think, was the most exciting thing to happen in 2017. And in fact, if you get Science News magazine, they come out each year looking back at the 10 most spectacular events in science. And Science News for January 6th lists the neutron star collision as the #1 event in all of science for 2017. And a Professor Avi Loeb, who's a theoretical astrophysicist and chair of the astronomy department at Harvard University, made the comment that this is more significant than any other event in the last 2 decades of astronomy. This merger or collision of two neutron stars. It was observed by Advanced LIGO and Advanced Virgo, the Fermi Gamma Ray Observatory, and 70 other telescopes on Earth and in space. This work involved thousands of astronomers and physicists. Hundreds of telescope hours were devoted, and dozens of scientific papers resulted from this. And the results have been quite impressive. In just a short time since that event, we know the following. We know that neutron star collisions are now a source of short gamma ray bursts. Up until this observation, we had postulated this might be the case, but we had no direct evidence. We know that neutron star collisions can produce heavy elements such as gold, uranium, platinum, things like that. It may in fact turn out to be that these type of collisions are the major source of these heavy elements in the universe. By studying the nature of the debris after the collision, we've learned information about the interiors of neutron stars, the properties of the neutrons which make up the stars under these extreme conditions. We've obtained a new measurement of the Hubble Constant, a number which tells us the rate at which the universe is expanding. There are a couple of independent measurements to date which are not in very good agreement with each other. This now gives us another independent measurement of that Hubble Constant. And we've been able to rule out dozens of theories on the nature of dark energy from the observations that were made, and the fact that a gamma ray pulse and the gravitational rays arrived almost simultaneously within less than 2 seconds of each other. So this indicates the latest for black hole mergers. This is something I showed in an earlier presentation back in November, but since November's presentation, there's been one more merger which has been announced. That's the one displayed here, resulting in the smallest black hole. So a little bit about the future of LIGO. Advanced LIGO should reach its maximum sensitivity sometime in 2018 to 2019. In the last run, they were observing gravitational wave signals at a rate of about 1 per month. A souped-up version called a LIGO A+ is expected to be operational by 2023, at which point we should be detecting 5 gravitational wave events per year.
Per day.
Per day. And then following that will be LIGO Voyager, expected in about 10 years. They should be observing up to 1 gravitational wave event per hour. And then it has been proposed that this will be followed by LIGO Cosmic Explorer, operating in the 2030s. It'll have 40-kilometer long arms, should be able to detect every black hole merger in the universe for lower mass black holes. And then finally, the Europeans have a project going called LISA, in which they're proposing to put into space an array of 3 satellites in orbit around the sun, which will be detecting low-frequency gravitational waves resulting from the collision of massive black holes. So gravitational wave astronomy is something very new, and the future is looking very bright. Thank you.
10 o'clock. You did the job. Good job, everybody. Any questions at all? Okay, that's the top news stories for 2017. We now have a format that will last for a long time, and I'm really pleased about that. Thank you for your attention. Any stories that you would like us to further research for you, we're certainly happy to do that as a group. And thank you for your attention. Appreciate it.